All right, super. Okay, folks, let's get started. Thank you for spending your Saturday morning with us. And this is session number 27 for Applied AI. I'm very we are going very strong. Uh, Super. A lot of familiar faces. Thanks for joining again. Thanks for attending these repeated sessions. For folks who are new, I'll give a little bit of context about what we do. So Applied AI Club is run by Praveen and I. So Praveen is not in this call. Usually one of us makes sure that we get in this. So we started this about like 6 months ago, and as a way of just interacting with our friends, like sharing notes around, how are we actually working with AI. And over a period of time, we started doing these sessions, and it became its own thing, right? So essentially, what we do is every Saturday morning around 10. So this is true 99% of the time. Every Saturday morning around 10 o'clock, we have an expert session. So where somebody from the industry comes and talks about a particular concept around AI, right? So that's the focus. It's on primarily operators who have a few years of experience in their belt, not necessarily developers, and that's the kind of people that we actually try to cater these sessions to. Most of the hosts or most of the guests are people who have worked with AI practically, who can share those tips, right? So that's kind of what we actually focus on. So all these sessions are free. Our past sessions are free. You can go check it out on our YouTube channel. We have all those videos up already, right? There are some very interesting ones over there. The second thing that we have started doing recently is some form of right. So took this concept from our MBA days, where we set up this group of people who can actually work on a particular project together. We're running one on N8 right now, and will actually continue. So if you're interested to be part of the the community or participate in any of these things, just go to Applied AI Club. I'll share the link in the chat, and if you could join, I'll add you to the club, and hope it will be useful. Cool, awesome. So that's about the club. I want to focus on today's session. So before I introduce you the presenter, so we a little bit of like housekeeping. Given that this is a large session, so we have close to 50 people today, I would request you to put your questions on chat. So I'll interrupt Sandhya. It's actually relevant, so that the questions are actually taken. Okay. And towards the last 10 minutes, we'll actually spend time on like answering these questions. So just keep those questions coming. Yeah, that's about it. So now coming to our presenter, again, we have one of our own, Sandhya. Sandhya is part of Applied AI Club. I'm very happy when our club members actually come and teach us. Sandhya is an expert on especially machine learning and data science. So I have like my exposure to that is mostly through her LinkedIn profile. I'm going to keep it very short. She currently works as a product manager for A&ML platforms at PayPal, and she has extensive experience across machine learning products. Going for a variety of companies in her past, right? So today is a session I am personally very interested in. I've been trying to work on like fine-tuning ML models, etc. LLM models, etc. And I find this concept it's going to grow pretty fast in the future. So I'm looking forward to it. Sandhya, over to you. Sorry for the botched intro, but probably you can share a little bit about what you do.
Sure. Thanks for that. And thank you for inviting me for the session too. I think I posted something on LinkedIn on a session I did in PayPal, and Vijay had reached out to me that, okay, can you just do a fine-tuning session for us too? And yeah, and I think here I am. So yeah, so I think I excited to be meeting all of you, and I was reading a lot about the Applied AI Club. I only knew about it after Vijay had reached out, but it's great. I think a lot of them are ISB LMs, and being an ISB LM too, I think that is something that's really nice to learn about this initiative. And yeah, and I think so. I am joining in from the West Coast time in the US. So it's a little late for me. I was just wrapping up work, and I put together something in the last minute and hope it's useful for you, and I'll keep adding in some more examples that what I'm doing at work too. So I'm building like the AI platform here at PayPal, and this is basically my customers primarily tend to be data scientists or researchers, ML researchers inside PayPal. So so it's more like providing the right, making sure that the right libraries are available to them on time, and then the right platform and all the compute that problems that we keep getting into. So making sure that all of that is seamlessly available. So that's primarily my job here at PayPal. Yeah, I started off as a data scientist, and eventually, like post ISB, I moved into product, and I kept working on data products. Yeah, and a lot of data ML, like using my past experience. So yeah, so I'll get started, and feel free to interrupt me. I know Bala said he'll be looking at the questions. I know Google Meet has this thing that you can't really see the chat and this one at the same time. But yeah, but I'll try to answer as much as I can during the session too, so that we can keep it interactive. Cool. Let me allow it. Can you see my screen?
Yes.
Okay, awesome. Cool. So today's session, yes, is on fine-tuning 101. And like I said, I'm building a fine-tuning platform here at PayPal too, but mostly using open source tools. We are doing like multiple initiatives, and I thought this could be like something that can definitely share with the larger public on how they can use LLMs better. And I just put together a quick about my career journey. This is something that Gamma did in last moment with my LinkedIn profile. Yeah, so like I said, I've been working with multiple as a PM in for multiple data products, and in my latest roles, I've been doing ML on the product side, and I now moved to the AI ML platform side of the house, because I was more interested in seeing how people are using this, using AI overall across the company, right? Yeah, and today's session. Uh, So this is how I plan to go about it. So first, just giving you a sense of like what is fine tuning, and then some of the applications in the real world. And I'll also share like some personal examples here, which I've not put on the slide, but I'll share like how we work and the kind of problems that we run into. And I think that there are also like important questions like when is it necessary to fine tune, and where can you fine tune, like the various platforms that are available for people. And yeah, and then how does fine tuning work itself, right? Like this is at a high level how I want to go about it. Yeah, and good. Yeah, so first thing, like, okay, what exactly is fine tuning, right? So I think this is, at least at a high level, I know most of you know this concept. So it's about like we have like a lot of pre-trained foundation LLMs that are available in the industry, and then if you wanted to do like a specific task better, that's when fine tuning comes into play. Like say you have like a lot of domain data for your company, or you want to train it to be like your twin. You have like a lot of digital twin, like for a personal use case. So when the context window is not enough, or like when it is good at doing some task, but the specific task that you want, like say being a doctor or being a lawyer. So if you want the LLM to be a better doctor or be a better lawyer, and also do it at half the cost, right? So when pre-training is like very expensive, so fine-tuning can be like a lot more cheaper and very dedicated to that specific task. That's usually when you can fine-tune. Uh, and there is like a complementary concept is also distillation. So that's something that also is very popular in the industry. I think with the whole the deep seek moment, I think everyone has been following, which is I think this technique has been there in machine learning for a long time. The distillation concept itself, but it is basically just teaching the from a teacher model, take it to the student model, and how can you make the student model adaptive and like it's like at a much lower cost, how you can potentially where you use a smaller model for the same functions that you are doing. But for this session, I'll just keep it to fine tuning. We will not really touch on distillation. But yeah, I just wanted to call it out that that's a complementary thing that can go after, or it can go parallel to fine tuning itself. And yeah, few applications. And if there are any Harry Potter nerds out there, I think so. Fine tuning is kind of like how you're teaching your portrait to actually behave like you, I think, in the Harry Potter world. So you can essentially communicate with the LLM and teach how it can assist you, and like it will potentially be like a portrait in the world that in the magical world, right? So that's something that you can do using an LLM, and yeah, so this is one of the top applications at a personal level that I've seen that people are using fine tuning for. And then there are like all these sophisticated digital twins that other companies have built, right? So they have built digital twins with all the data that they have on the political leaders, and then you can actually simulate environments where how a particular political leader would actually make any decision out there. So this is essentially feeding in all the news information about a particular leader, and then you can potentially use like a reinforcement learning, like a reward that you can that you can give to the model, and then every time it behaves the right way, you can actually create that simulated environment, and yeah, and you can create this overall and this the real pressure kind of environment with it. So this is some more applications of fine tuning, and I think very recently Google created something like on-device fine tuning, which I think so, which basically uses reinforcement learning. So it either gives like a reward or a penalty to a bot, and then based on that, it keeps learning how to do a task better. So yeah, so I think reinforcement learning concept itself came from robotics primarily, and then it moved to the software world. But yeah, so this is just a thing of how compute people are starting to make compute cheaper and start how you can actually have it on a device. So otherwise, when you're doing it on cloud, it's like a very expensive affair to actually fine tune models. Yeah, so these are some of the interesting industry applications that is happening out there that's come out in the news. But other than this, like in my work itself, so some of the key areas how we have been using fine tuning, I think the most classic use case is that of training the chatbot. Like so basically the PayPal assistant, that if someone is using the PayPal assistant, it's essentially using the fine-tuned model in the backend, and we went through the entire journey, right? Like how you could potentially start small on building like a RAG application, and then eventually you can fine tune a closed source model, and then you can go on and fine tune an open source model. So we went through the entire journey. So the people, so a chatbot or an assistant in any company, so that could be like a very classic use case industry application. And yeah, and also all these shopping agents that you're seeing. So these are is like one more agentic commerce is becoming very popular here. So that is one more area where we have been using fine tuning. So basically use all the customer data and then simulate environments like and how do you train the LLMs to actually make the right purchases or do the right transactions. So this is something that is still under research. But yeah, but these are the kind of applications that I'm working with the different ML scientists inside the company to fine tune like some more real world applications here. Yeah, and so now that we saw like what is fine tuning and some of the applications, I think the next part that I wanted to touch upon is like when to fine tune itself. So like I said, so fine tuning typically takes a really long time, and also it takes a lot of compute. So if you're using like a lot of data to fine tune, it can take like I think so thousands of dollars of compute that it could potentially take. But if you can also fine tune for as less as 50 to 100 examples. That's usually how people start off with learning fine tuning. Start with 50, some 10 to 50 examples. So it's always the quality of data that matters, and not necessarily the quantity. So yeah, so that is, so because of that, so keeping that cost in mind, there are like a lot of the other ways that you can do before fine tuning itself. It's like you can do like a simple crawl, walk, run approach. You can always start with a prompt engineering, which a really good prompt. I know there was like a session even last week about prompt engineering masterclass. Like how do you give a role, goal, and then how do you customize each one? So that is usually like the best starting point that you can that you can start off with. And then depending on the use case, if you think there's like a lot of external knowledge required, RAG is a good place to be in. But if it's more about summarization or like adapting it to specific task, that's where fine tuning, like say you want to have like a company's brand voice a much in a much better way. So you have built a brand voice over time and you want the LLM to pick it up. So that's something that you would potentially use fine tuning for. But for a chatbot, it will be like something that needs the latest information about a customer. And in that case, a RAG application would be really good because it needs to retrieve the latest information about that particular customer, right? And typically for the customer support that we are talking about, it's like a fine tuning plus RAG application. It's always used as a hybrid and a combination. uh, yeah, and also I think now with the N18, I think Bala talked about like how there are like N18 study groups that like the way we had in ISB, and so that is also like one more step like before, like maybe like the crawl, walk, run, that will potentially be like the walk step. Try doing something with the agents plus tools before moving on, and if you still think that the task is not good enough, so you want to improve the brain of the agent, right? So then you can also use fine tuning. So when I say brain, so LLM becomes the brain and agent kind of becomes like the hands, like the tools that you would use. So yeah, so that is something that you can feed in for the agent to perform better at a specific task, right? When you give it examples, enough examples on how you want it to behave. So yes, that is a little bit about when you can fine tune. And yeah, so next, moving on to where to fine tune, right? So there are like multiple places that people
Sandhya,
have. Yeah,
sorry to interrupt. There are a couple of questions which might be relevant to pick up right now on
yeah,
the chat.
sure. Let me see. I will.
Or I can just call them out.
Yeah,
Let me
I'm.
see.
Yeah. Okay. So I see Ravindra. He had a question on. Did you build all dataset needed manually, or you had some automation for building dataset in the needed format? So when it came to like a chatbot kind of an application, we had like a pre-built data set, right? So basically, you actually used to train the customer service reps. So yeah, so for some things there were like some pre-built data sets that also served like an eval data set, but uh, when it comes to certain training algorithms, it actually changes from algorithm to algorithm. So for something like a supervised fine tuning, maybe I'll go through that later, right? For a simple use case, so for there we need to build our own data set manually. And for something like say a reinforcement learning, you have like open source environments available which will simulate all these digital actions. So every time the model is performing an action, it will get a reward or a penalty uh, depending on what we want it to do, right? Like say I wanted to respond in a certain way, I wanted to respond in a more professional way, then I give it a reward. Otherwise, I'll give it a penalty if it starts hallucinating and responds in a different tone. So yeah, so stuff like that. So those are like other training environments that you actually have available. So that's on the first question. So the next, Sriram, how to decide when to fine tune versus when to prompt and achieve model adaptation goals. Yeah, so I think I can. So I think so. Usually, you set like an accuracy or a benchmark. I had this open, right? So when do you want the optimize? So, like you see, so first you always set a goal, like what is it that you want to achieve, and then you also build like a simple like an evaluation data set. So there are ways to build evals automatically. Like I think this is something that OpenAI provides, like an API through which you can build evals. So you tell that this is the goal that I want to achieve, and then this is the kind of evaluation. And first you try prompt engineering, and maybe you can also set like my goal is to have say 80% accuracy, right? So if you have like once you have that 80% accuracy as a goal, because at the end of the day it is like it's probabilistic in nature, these models. uh, so yeah, so once you set that goal, first you give prompt engineering and you see how much you're able to get accuracy, right? You try different multiple scenarios and then you see just with prompt engineering how much accuracy you're getting. And if that is meeting like say 70% of the goal, or 70% or up to 60% you're able to get prompt engineering, but you have like a more specific task, then you move on to fine tuning. And even within fine tuning, you have like start small with a closed source model and then you move on to like open source fine tuning, right? So there are like steps within that too. But yeah, but usually it all depends on what is it that you want to achieve and how much accuracy that you want to achieve for a specific task. And yeah, I think, does that answer your question, Sriram? Okay, good. I'll move on. Okay, thanks for the acknowledgement. So next is like, what are the signals to understand fine tuning is going to be better prompting versus prompt plus RAG? Yeah, I think it's the same thing. So what is our goal? What is the goal for our accuracy and what is the eval, right? You start off with the goal always. And what is helping you reach that goal faster? And yeah, maybe prompt plus RAG is something that you can always start off with, and then figure out like how that, like say you want to add like brand voice is not coming as well, like certain tasks that's not performing as well, then you start giving adding like a little more fine tuning for the model to start doing that. Yeah, I think there is like one more question on what are the best practices enterprises can follow to prepare clean and compliant data sets for fine tuning and bias or leaking sensitive data. Yeah, that is always a challenge, like because anytime enterprises are doing something, you always have people who are trying to jailbreak your system too. Uh, but yeah, but I think just to start off with, I think for clean and compliance, so I think when you go into these APIs that OpenAI and like there are like few other open source things that they provide, right? So they will have like they actually have like a list of things that you need to follow that can be like a great starting point. So you can they have like a whole list of edge cases that this is something that, and at the end of the day it's very generative in nature when it comes to the evaluations. So yeah, so I think so this is like how do you make sure that the spellings are right, and I think there is like a good list actually. I'm trying to find that. It was on toxicity and all the different things that we can fine tune on. Yeah, I think so. There are some things like safety checks, right? So you need to have like advice, harassment, hate. So these are like I think some good yes, any sort of propaganda. So you always want to have like a neutral voice. So yeah, so these are like certain things that you can definitely keep in mind when you want to move something to production, right? So none of these should be yeah, I think so people have made like a pretty comprehensive list of uh, what kind of things are considered harmful and what is considered neutral, right? So this is and yeah, obviously embellish it with your company's data. Yeah. So these could be like a good checklist for anyone to start off with at an enterprise level. And yeah, Rahul, I think yeah, Rahul has one more question. Yeah. How do you make a case to invest in fine tuning? Yeah, I think at the end of the day, it's always you start off with evaluation. I really like this cycle, right? You start off with the eval, see how much your accuracy, and if you're not able to reach it or not able to put something into production because it's not performing task to the level of accuracy that's required, that is when we need to start thinking about like fine tuning and how you can build a model around it. Uh, yeah. And there is, which practice are you following to check the LLM response accuracy? So there is it actually keeps changing like because LLMs are generative in nature, evaluations become really important. So yeah, so I think we have like the general safety guardrails that you have to think about, and apart from that, it is like a few responses that you can potentially tell the LLM on what is right, what is wrong, and how close. So there are I think simple metrics which like I mean, yeah, I don't want to get into the technical details, but there are like certain metrics that the ML scientists are generally aware of that tells like how close, like how similar it is to the answers that is being expected. Like I think cosine similarity is something that's very simple, but apart from that, there is like a loss function that you train, and every time it goes off, the loss function kind of keeps giving like a response that this is not right, and you start training it to do what you want the LLM to do, right? So yeah, so I think there are like some standard metrics for sure, but a lot actually depends on the evaluation, like how strong of an eval that we are able to create. Yeah, I think it's definitely a combination of the two. And yeah, so I think the next question is, can you keep doing incremental fine tuning as more data becomes available? Yeah, yeah, I think that's something that so this is very common with machine learning applications in general, right? So with ML applications, every time new data comes in, so the model starts becoming old. Like unlike typical software applications where you can just give it certain functions and it will continue to run. Data tends to get stale very quickly. So you need to have like a good retraining frequency for machine learning models. So this has been like a standard practice. Like that is how machine learning models have had to be maintained for a while, and that same practice kind of goes back into fine tuning, right? So where you can continuously you need to keep updating the model. I think over whatever frequency we see that it starts going off rails, right? Because retraining a model can also be expensive. So we need to know that what is the right frequency at which we want to fine tune. And that is where RAG also comes in. So RAG always helps keep your answers fresh. So if you're using like a combination of RAG plus fine tuning, we will be able to make sure that you're giving the best, that you're giving the most current or like the most recent information for your answer. So yeah, so I think definitely a combination of RAG plus fine tuning, and then yeah, and then find a frequency that at which you need to retrain the model. And when with time models get refreshed, can fine tuning help then complete retraining the model? Yeah, I think the same this one. So I think fine tuning is definitely a lot, probably uh, like it's I think it's probably cost like less than 10% of the cost of actually building the whole foundation model, right? So definitely fine tuning can help with retraining the model. And complete retrain, I think when you say complete retrain, so there is something called like full fine tuning where you are changing every parameter inside the model. and there are like some parameter efficient techniques, right? So people usually tend to prefer the parameter efficient techniques where there is like a layer that's frozen, and then you just train a few layers which are required for retraining the model. So you keep like the base performance same, and then you train like the only the essential layers to make sure that the model is behaving how you want it to.
So time check, just
Okay.
35 minutes. Yeah.
Yeah. Yeah. I hope that gave you like a high level this one on like whether fine tuning can help, Venkat. And obviously the previous answer RAG also definitely uh, yeah. So that is also like part of it. Okay. Cool. Yeah. Thanks for the questions. I think it's good. I think maybe uh, yeah. I hope I was able to answer at least like at a high level that what how you can fine tune. Uh, and so we were here, right? We were at this when to fine tune piece. So yeah, I think so. Next, I wanted to just share like a couple of places like where you can fine tune. I think some of the questions I did go into what I had prepared. So yeah, so there are some models. So I think there are like multiple options that you can fine tune, right? So depending on the flexibility that you need and the effort that you need to put. So there are like different kinds of options. So there is like closed source models. So basically none of the weights are open to you. So for that, that takes in the least effort, but and also obviously the least flexibility that you get with it. And then there are like a lot of these open source fine tuning options. That's kind of, I think everyone keeps seeing like the latest benchmarks from Hugging Face and all of these different places that you get. So that offers you the highest level of flexibility, right? And even here, like say like and Vertex also offers like some of these closed source fine tuning options. I had some of this open, like how the closed source fine tuning options itself look, right? So this is on what Azure offers. Azure offers like how do you do the continuous fine tuning, right? So this is something that you can all. This is all I think a pre-built models. Right. Where does it start? Yeah. Well, so you can, I think there are like UI that these people have that has been created, which takes out a lot of this complexity, and anyone like say even product managers like us can also potentially start fine tuning, or any developer who doesn't really if even if you do not know the ML all the ML parameters that needs to be fine tuned, you can still start, right? So remove the basically abstracting the whole fine tuning out. So you just need to fine tune the model. You can choose. So Azure just often offers all the GPT models out of the box. So you can choose which model that you want, that you prefer to fine tune. And you can choose, you can just add your training data to it potentially. And then if this, there is like the automatically gives you like the batch size, how many turns that you wanted to do, the number of epochs, right? Like how many times you wanted to go and learn and improve that loss function that I was talking about. So yeah, so these are like different things that you can configure on here. And yeah, and I think there's that, and then you can also upload like the validation data set. So that becomes like your eval data set that you want it to test against. And yeah, and I think that's pretty much it. I think it's they're making it pretty straightforward for you to go, and for anyone to go and keeps just start fine tuning, right? Because developers, even a developer is able to fine tune, and not just the ML scientists. So this is, and then this kind of falls in this initial this one, like the least customization and the least effort. And similar to that, even Vertex, Google also offers some fine tuning options. So you can go, you can do like some custom tuning. Yeah, I think so. So I think it's very similar to the uh, to how Azure is doing, but it is just that Google has a lot more models that you can potentially fine tune. So it's not just the Gemini models. They also have built like a model garden where you have access to a lot of these other foundation LLMs like the Quen and DeepSeek models. And yeah, I think like a few other popular LLM families that you can also access through Vertex, right? So these both of them have like a simple interface that you can use. And this one is actually Llama Factory that I put here. So Llama Factory has, so definitely you can go and do like the full blown fine tuning. You'll see a lot of scripts online where you can do the full open source, full customization and high effort. And but you also need like, depending on how much data you have, how much GPU compute, all of that is also required. So yeah, so definitely you can do that, but also fine tuning as a service. So this is also something that Llama Factory offers, right? Like if you see here, hope you're able to see my screen. It's good. Yeah. So I think it's very similar, but it gives you like a lot more options on open source models that you can potentially use to fine tune. So I think that this one is like an example of how you can do like a Quen model. And yeah, like if you saw the Azure, it because it is closed source, it doesn't give you like as many options. Yeah, this doesn't go in. Okay. I'm not sure. I think this model is this one. I'll make sure to share this video also when I'm sharing some resources. Some of these links I think I'll add it. I think it's not playing right now. Reason, yeah. So yes, I think that basically the point is there are like a lot of easy ways that one can start off with fine tuning, and like I said, again the same crawl, walk, run approach. So always start off probably with a closed source model. Once you decide that fine tuning is required for you to reach that accuracy goal, right? So you always start off say with a closed source model, and then you can move on to like the hardcore open source fine tuning. And even at PayPal, that is kind of the approach that we took even for building the PayPal assistant. We started off with the Azure OpenAI, this basically with the GPT 3.5. So even GPT-4 was available, but when once you fine tune it, GPT-3 or GPT 3.5 can do like much better at with like much less parameters, right? So we started off with that, and then we moved on. Now we are like going towards like we have built like an open source model, like a Llama that we have built. On top of that, we have built like a chat assistant on top of it, because especially at an industry scale, like an enterprise scale, you start hitting those token limits very quickly. And yeah, but for personal projects this should be good enough. Like you can definitely like the closed source one should be good enough. And all the token limits, and also like the amount of inferencing cost also, so all of that comes into picture. And yeah, and I think we were able to achieve like very similar with some optimizations that we did. We are able to achieve very similar. Latency becomes like very important for us to start calculating, because you don't for the best customer experience. So yeah, so we are able to achieve similar levels of latency that what Azure is giving. So yeah, so that's something that was a journey that we went through. And yeah, so that's about where to fine tune. And next, yeah, so how does fine tuning itself work, right? So this is probably like so yeah, so I think so we talked about pre-training and giving it a specific task, but what is really happening inside, right? So you and how one can start off. So you have like these open source families and then closed source. I think Llama, I think the latest versions are not open source anymore, but yeah, and some of the GPT have actually moved to open source, like the latest models, but still there are you have like open source models where all the weights are known for you, and then the closed source models. And then you need to first think about like a strategy, like what is the first strategy, how you want to approach fine tuning itself. So there are like multiple options. Here I just listed like the top, the most popular ones, right? The supervised fine tuning, reinforcement learning, instruction tuning. So you choose what is the approach that we want to do. And within this approach, there are like multiple techniques. So if you want to change all the weights, then you go for full fine tuning. So that is also more compute intensive, and also at the same time, there are like there's like another cons in the sense that the model can completely go off rails. There are certain things that it already knows, and it starts hallucinating a lot more in certain aspects. Maybe it will be better at the certain task that you're looking at, but it starts hallucinating on other tasks, right? So full fine tuning has those cons. So that's kind of where the PEFT, like the parameter efficient fine tuning, started coming in. And the most popular ones are called it's low rank adaptation and quantized low rank adaptations, LoRa, QLoRa. And yeah, so for LoRa, like I said, there are like multiple neural network layers that are being used here. So you freeze like a set of layers, and you're just using like the other layers for doing the fine tuning. And when it comes to this quantized, so whenever people say quantization aware, it is just that there are like other techniques that where you're using the memory even more efficiently. So LoRa is already freezing some layers and using just the other parts. When it comes to LoRa, like even within that, it has like a but more memory efficient techniques over there. Yeah, so that is those are like the techniques, and these techniques. So say you can do supervised fine. So it's like a MS to N matrix. So supervised fine tuning can use any of this. Reinforcement learning, you can use any of these techniques. So yeah, so the approach and these techniques is like an MS to N kind of matrix, right? If you think about it that way. And yeah, and all of these kind of go within like some certain frameworks that we are talking about. So there are very popular open source frameworks that I have listed here: Hugging Face, TRL, and this is like the Unsloth and Axolotl. So these are like some popular open source frameworks. And then there's obviously the closed source ones, with Azure OpenAI and Mistral. So yeah, so these are the frameworks that you can use for fine tuning itself. Yeah, maybe I'll just do this one slide to give a little bit more this one tuning strategy, like on what each of these models that I talked about there do, like they are at a very high level. And then I think I'll just take some questions. I haven't checked the chat, but yeah, I'll just finish this part and then we can go spend the last 10 minutes on questions, right? So yeah, so supervised fine tuning. So this is probably like the most intuitive way to understand, and very similar to the supervised learning that was also in machine learning, right? So you have like a set of label data from which the model is learning from, and you basically what is the input, the output, and how close the input is to the output. So when it comes to Q&A, there were questions on how do we determine the accuracy. With supervised fine tuning, it becomes a lot more easier because you have like a set Q&A, like what you expect the customer service rep to answer, right? Like you already have like that already set. So that is one of the popular techniques. And this is also like one of the least compute intensive techniques, right? Supervised fine tuning. And then there is the instruction fine tuning. So yeah, so this is pretty similar to prompt, like how you're doing like prompt management, prompt engineering. And yeah, I think you can have like a role, goal, like all of that, how you set. Yeah, this is very close to the prompt engineering and how you give like very specific instructions for the model to follow. Like, I think, but it can also be something that the model is learning through patterns. Like say for in PayPal, like one of the key things that we are using instruction fine tuning for is like in detecting fraud. So every time it figures out, like, so we give it instructions that you keep looking for patterns where PayPal is potentially looking for is finding losses. And then in fraud analysis, this is something that it keeps learning instructions from, and then it starts improving the model on how you are identifying a fraud transaction versus this one. So it's like continuously adapting to those techniques, right? So yeah, reward models. This is like very popular. So reinforcement learning and reward model tuning. So these are again very popular techniques. So I think reward model tuning. is, I think, the very popular. I don't know if people follow the all the papers that are being published. So direct preference optimization is like is a very popular technique. So essentially, if you're a PM, I think it's like it's an A/B testing framework. So you have like a model A generating A and then model B generating B, and then you tell like what is the preference that you have for that specific output that the model is generating. Like if you're answering in a more neutral format versus you start hallucinating because like say I think so Grok started telling something about like the how it's anti-Semitism and all of that, right? So then you start giving it in this one that this is not how I wanted to answer. So that becomes like the reward model tuning, which is like a little different from the actual reinforcement learning itself. So you're giving it a reward just for your preference, like how you want to tune the answer for yourself. Uh, so reinforcement learning becomes so this is the larger the reward training. Like say you want to build like an agent that is doing something. So every time it does something right, you're giving it a reward. Every time it doesn't do something right, you're giving it a penalty. And how you for this is where you kind of you build simulated digital simulated environments. I know there is a question on how do you build the data sets. So for supervised fine tuning, it's like a very different dataset approach, building approach to reinforcement learning. So reinforcement learning becomes like mostly almost fully simulated. For supervised fine tuning, this is where we need to craft these annotations. So either we can use an LLM to build the datasets itself, or we can also like have it like a human annotated datasets. Yes, that is something that used to happen a lot. That was probably the most expensive part of machine learning pre AI or pre LLM times, right? But now we can actually tune an LLM to start generating the kind of data sets that you want it to generate to. So yeah, so some of these human annotation work is getting taken up by LLMs itself for building the data sets for this. So yeah, so I think in reinforcement learning, so DPO is actually technically not. I think this is like a typo here. So DPO is technically just the reward model tuning. It's not technically a reinforcement learning technique. So yeah, so PPO, GRPO are like the most popular reinforcement techniques, and each one has its advantages in terms of like how the compute is being used and how fast you can train it. Um, right. So yeah, so I think these are like some of the and then there are also I think there is a question on can you continuously tune. So I think that is also like one of the things that is actually covered. So you can potentially it's like a lifelong learning that you can potentially give a frequency at which you want to retrain the model and all of that. And I think how do you keep adapting over time to new data? So yeah, so this is like a hell of a category. I think this is mostly like the most popular techniques that people are using. And when models are in production, usually it's like a combination of, say, a supervised fine tuning plus a reward model. So most of them is like hybrid approaches. But yeah, but for the sake of easy for easy learning, initially I think these are like the specific topics that each one can do. And yeah, so preference based, I think the other thing was how do you treat with human feedback versus AI feedback? So this is RLHF, RLAIF becomes giving a prompt, the human basically evaluating the responses and telling whether it's right or wrong. And depending on whether it's a math, if it's a math Olympiad kind of question, the kind of benchmarks, so that becomes like a much more expensive expert kind of human feedback that we need to give. And otherwise, now we are also training it to get like AI giving feedback back. So this becomes like the RLAIF. So yeah, I'll stop here. I had like I think this is the rest is basically going into a lot more detail on certain techniques. Uh, yeah, and I'll
Yeah.
take if
Your
there are
questions.
questions here. Sorry. Yeah, you said something, Bala. I missed.
We have a few questions already ready for you.
Oh, awesome. Cool.
We left at Khyati's question, so that is still pending.
Okay. So Khyati, fine-tuning may sometimes modify the model to a very good performance one task. Yeah, very true. And for another, is there a way to avoid it while still achieving a fine-tuned model? Yeah. So Khyati, I think this is where I think some of the parameter efficient techniques come into play. So that when you do full fine tuning, this is like a bigger risk that we go through when you train every weight when you update every weight the model is having. So that is one way to preserve most of what the model already knows. Uh, Parameter efficient techniques, and but apart from that, I think it's also maybe giving like the better guardrails and instructions. So those are some non-negotiables that you can always feed into the model. So there are like, I think there are out of the box solutions for guardrails. I think there are like companies like guardrails.ai, and I think there are like few more where you can have like the safety bias metrics that are pre-built into the model, and you can make sure that model never goes off rails there. And yeah, I think so those are like from a safety bias point of view that you can think about it. But from a task perspective itself, I think parameter efficient techniques, so that's something that should help in most cases. Yeah. Yeah. And next is Avinav Shrivastava. Can we perform fine-tuning to LLMs for safety critical applications like medical and aerospace to be higher than 99.9%? Yeah, I think these are like very specific cases where fine tuning is definitely required, right? So just simple having like a RAG or an agent will not work. And we definitely need an LLM uh, that is like very highly fine tuned. But again, this is very similar to how we are also how the full self-driving that Tesla has already rolled out. So even there, the accuracy is expected to be 99.9% because people's lives are at stake. So yeah, so those were again, I think, continuous reinforcement learning that the model has kept learn. So initially they just gave it to a few people, and then they kept learning from that, and eventually, I think all the popular the Waymo, Tesla's full self-driving, all the self-driving this one is also using. So yeah, so definitely I think there is like a combination of fine-tuning techniques that we can use, but this is something that will take like longer and better simulated environments also. So I think simulation is when it comes to all these self-driving cars. I'm not familiar with medical and aerospace. I'm more familiar with like the self-driving, but I think the question is more around accuracy, 99.9%, right? So the simulated environments are like a lot more realistic, and it's something that they take like a lot of care. There's like entire teams who are just working on how you can simulate the right data for building these very highly safety critical applications, right? So yeah, so I think definitely, I think fine tuning an LLM helps, but also that is in combination with building that right simulated environments and making sure the model gets the right rewards to do the right things. Yeah, and gets penalized for the right thing. So it's like, and it takes like a lot more time for this to happen, like a lot more data and a lot more time. And I think he also has one more question I've never had. Does original LLM performance go bad when fine tuning is done using bad input data? Yeah, I think that's, yeah, it's like garbage in, garbage out, right? But yeah, but I think there is like just a caveat to the garbage in, garbage out. So when while this was like even more true in ML because like the whole input data was kind of what it was learning from. With an LLM, it already has like some pre-built knowledge. So there is like some part, something that it probably it retains from the original model, and it probably does not go completely as bad as, say, a standard like a traditional ML model, how it used to happen. So yeah, so it has got like a little more guardrails inbuilt from the parent model itself. But bad input data is always like, yeah, I think that's something that we always need to be aware of. The quality of data. So even 50 examples of high quality data is better than 1,000 examples that's like poor quality, right? So yeah. Uh, Hope that answered your two questions, Abhinav. And I think there's a next question. Any experience you'd like to share on LLM plus text to speech for chatbot? So text to speech, I think we are just using like some out of the box models from that Gemini is offering when it comes to text to speech. I mean, I don't know if we faced anything specific. It was more about the quality of responses that the team was optimizing towards, the ML team was optimizing towards, than just converting it to speech. Yeah, for that we just ended up using like an out of the box model from Google.
Yeah,
Uh,
I have a question based on the last question you answered. That's why I not wrote on the chat. May I ask?
yeah, go ahead, Yash.
Yeah, so you mentioned, right, even 50 to 100 examples are good. So in that case, do we require fine tuning and or I can always pass in the prompt those 50 examples, or it's
Yeah,
not a good idea?
yeah. I think that's a great point. I think, but especially with increasing context windows, right? We can just pass like 50 to 100 examples, and you can also build like custom GPT for yourself. That's something that can be done. But only thing like during production, I think so that is where usually uh, people tend to want like a fine-tuned model rather than just doing like a prompt tuning. I think that's just like it's probably like the um term that generally people use is prompt tuning, right? So just instead of prompt tuning, you can fine tune. So prompt tuning is essentially one of the ways that you can fine tune a model. Yeah,
Okay.
yeah.
Okay, so prompt tuning is nothing related to prompt engineering, it's related to fine tuning. I was not aware. Is this?
So prompt engineering, prompt tuning. So these are all just. I think so. I think it's more about like how you're constructing the prompt itself. But
Okay.
essentially, it is about like how you're giving a prompt to the model and the kind of response that you end up getting. Uh, so yeah, so I think, I mean, it can be considered as a version of fine tuning. So it is just like along with the instruction tuning. So it's like a precursor to that. How you can give like from just through prompts, how you can give an instruction to the model. So yeah, so I think it is different. And yeah,
Okay. Thank you.
sure. And I think there is a question on what is the cost range like for different kinds of fine tuning, the quality improvement we see in each. Mm, yeah, so the cost range is something I think that's so I think like I said, so supervised fine tuning is probably the least expensive one, but and then reinforcement learning can be like harder for us to replicate because of like the how many turns, like even training itself actually has like part of it is inference itself, because like every time you train you put the action, like say you have an action, then you have a reward or a penalty attached to an action, right? So you can get a reward or penalty only when the model goes, it deploys, and then you have like that inference, and then it comes back, and it comes back as a response to the model. So that becomes like an even more expensive way to train. Supervised fine tuning is more you just train every.
What would be the range of this? Is it like hundreds of dollars, thousands of dollars, tens of dollars?
Uh, so it is actually the okay. It kind of becomes like either at a token cost if you're using closed source fine tuning, so they charge you in terms of tokens. So right now, inferencing is becoming quite cheap for this one. So there for a million tokens, I think Google and all end up charging around like some $5 to $10 is what they're charging just for a million tokens. I mean, this is again in closed source fine tuning. In open source fine tuning, when we have, so I think here we are using like our own GPUs and our own compute. So that is where majority of the cost goes for us. So if you're going to maintain GPUs in the long run, it makes sense only at an enterprise scale to actually maintain GPUs at long run. So that's like they charge about 100K per month for like I think depending on how many GPUs that you're getting, around like some 16 GPUs that we got. For that one they were charging around like some 100K per month. um, so yeah, so that's something that Nvidia was charging. So it also depends on the type. So B200s, that GPUs are like much more expensive than the H100s right now. H100s are more popular, but yeah, the newer versions are like more this one to get. So that becomes like a demand based. This one, if you're directly getting the compute, then that compute usually you need it for open source in an enterprise scale. Uh, yeah.
If I may, there is both Kaggle and Colab actually provide free GPU on a weekly basis or on a daily basis. The limit is small, but if you are training on like small number of data sets, I have even fine-tuned a speech to text model with about 10,000 samples, and I was able to do it completely free and not spending like a single dollar, right?
Oh.
Just with the GPUs on Colab and Kaggle, and it's available for all the users. You can just go connect GPU and play around with that. Yeah.
That's cool. Like, was it like T4, like some machines, like so
T4 on Colab, and in Kaggle it was 2 GPUs. I don't remember the version number over there.
Okay.
Yeah. It's pretty. I mean, there's a lot of. I had to do some optimizations to reduce the number of samples and other things because I was working with voice data. But for data, it's pretty straightforward.
Okay, that's good. Yeah, I think maybe yeah, if someone wants to get started off, maybe we can also share these resources. Yeah, yeah. I think there are. I think even yeah, Google also was offering. So they had like a few places where you could actually. Where is this? Yeah, you can actually start for free for a few GPU. I think there is like a little bit of limitations. Yeah, and but they were asking for like the quota billing, so I didn't register before the session. But yeah, but yeah, I think like Bala was telling me there are like quite a few options that you can start for just getting started with fine tuning. Yeah, I think that change happens when you want to put it in production and how many people use and then how many people are consuming it, right? That's where the cost really kicks in. Cool. Hope that answered your question, Rochan. And then I think the next is about can you explain more on fraud identification example you spoke about? Is it a classification model, a rule-based model combined with LLM-based fine-tuning to identify new features, new rules based on the fraud detection? Yeah, I think that you're like mostly on point, Keval. Yeah, it is. So I think so. PayPal has been in the space for a long time, so they have most of it has been like the classical ML models, but traditionally we kept using like some rules engine. So this is like a post-training layer, that rules engine that kept continuously every time we start seeing a new pattern. I think manually we kept updating the rules engine. So this is something that we are doing in parallel with that manual update. We have not completely moved off the rules engine yet on top of the ML models. But this is like an exercise that we are doing, like continuously trying to adapt an LLM to also identify these different fraud scenarios. Yeah, because I think when it comes to this one fraud, I think yeah, it's like that probably like that continuous beast that keeps changing over time. So yeah, so I think we're building like both in parallel that goes on for fraud identification. But yeah, I think your thinking it's like kind of spot on. That's kind of the approach that we are going towards. Yash, you have one more question. For software engineer aspiring to enter this AI engineering, how much traditional AI ML is required? Yeah, I think this one there is like a lot more abstraction that is happening, right? Like I showed you the models that how there is like a layer that's built, so you just need to know what should be the parameters that you're inputting. So that's mostly I think that's what's required. I think you should probably be better at like the data engineering part, like how to build the pipelines for that to speeding into the models. And there is like a small part that can be abstracted out at least at a high level, right? So in fact, a lot of the software engineers that I'm working with, they have been data engineers in the past, and they don't really get the whole statistics part. But at the end of the day, because we are working in collaboration with these ML scientists, so they are able to build out that platform for them just by understanding like a few parameters that's required. But a lot, it has made it a lot more democratic, is what I would say. So I think it's like a lot more easier for a software engineer to aspire to get into AI ML than an ML scientist coming back to the software engineering field, right? So it's like that reverse, this one, I think if you're on the developer side, you're probably at a slight higher advantage uh, for entering the field. Um, then there is Rochan had one more question. How much time does it take for different approaches, time and skill cost? Yeah, so I think for supervised fine tuning and like this instruction tuning, I think it's a more straightforward approach. I think that's something that's like a lot more intuitive. When it comes to reinforcement learning, that is where the skills start to matter a lot more. Yeah, so I think supervised fine tuning has become like quite abstracted right now, and this is where even automation is not that straightforward when it comes to reinforcement learning. Being able to create the right environment, and then being able to build that reward training mechanism, that reward penalty mechanism for the model. So that's something that becomes very domain specific, and that's something that you really need to understand the business problem, and you really need to understand what kind of data that you need to simulate for the model to learn. So I think that is the highest, that reinforcement learning approach is probably at the highest skill end, and supervised fine tuning is probably on the lowest on an x-axis, if you see, um, from an approach point of view. Uh, and I think we are over time, but I'll just take these last 2 or 3 questions. Which fine-tuning technique can work when supervised learning approach is not feasible with no trained dataset available? Yeah, I think this again is, I think the for the reinforcement learning is where you actually don't need a trained dataset that is available. You're just simulating different actions, and you're training the model on performing the right action or behaving the right way for your specific scenario, right? So yeah, so that becomes when I mean, the amount of data set that you do not have, like that's when this particular skill comes into play. Otherwise, it's about maybe if you think that some of it can be like more generic skills, then maybe some prompt tuning or link instruction tuning. So one of that should also be helped if there is not enough data that you're doing. And Yash has I have a use case and don't have any evals. For any keyword, get list of movies, Independence special 30 movies or Diwali special movies. I'm using prompt engineering. Can fine-tuning help in this scenario? Uh, yeah, I mean, fine-tuning can definitely help, but I guess I think it's like a good start. Maybe prompt engineering, I'm not sure, like, what are you seeing? What kind of results are you seeing? Like, is it not working for you, or because like maybe I think at the end of the day it depends on because it seems like a personal pet project, right? So what is our accuracy goals? Like if prompt engineering is able to solve it, yeah, I wouldn't put in a lot more effort there. But yeah, but it does sound like a fun project. Fine tuning
No,
can definitely, yeah, go
yeah,
ahead.
it's not a fun project. Basically, in our like, so I work at Samsung here. What happens is we create rows, let's say Independence Day special rows or action movies or comedy movies
Oh,
for
okay.
you. So it was happening manually. Curator was using database filters on the screen. So I provided the curator a prompt and sorry, just a input text box, and I create the prompt at the end. But now the people were asking me, sometimes we are not getting good results, and can we do fine tuning? I'm not that movie enthusiast. I cannot tell, right? Even 30 movies exist, or what should be the good result, right? I have watched 50 movies in my lifetime, and I am not aware about the 10,000 or 50,000 movies which exist.
Mm.
So I don't know how fine tuning should be done. I don't have any data set, right? Also, of any actor, particular movies, particular shows. There are various combinations. So, and somebody also asked me, can we make evals on that? I thought if we had evals, why I would use model? I will simply store in my database and feed them. So a lot of questions which I'm not aware. So just thought to ask
Yeah.
here.
Okay. I think that clarifies. I mean, when you said 30 movies or something, then I thought it was like a more personal kind of project.
No.
Yeah.
Because we tried to create a row with that, because 30 movies we need from LLM, then I find in the database, because in my database, all movies are not there because of contract issues. So even if 15 to 20 are there, I then create a row with that keyword and the movies which have been mapped to my database.
Mm-hmm.
So this is the use case. We are creating thousands of rows and trying to personalize those, but the rows accuracy and some more content, I was thinking if I can improve on those.
Yeah. Have you tried RAG? RAG as a service, I think that.
Yeah, RAG. The problem is all is structured data, right? So the keywords I'm looking is
Okay,
not available in my data.
guys.
Yeah.
Sorry to interrupt, but we are already over time. Let's close
Okay.
the questions. Yes, I would request you to ping Sandhya
Yeah.
because she's part of the day club group only. Just use the
Sure,
WhatsApp
sure. I will.
and we can take this offline. Yeah, please
Yeah.
go
Okay, thank you.
Sure. Yeah. Sure. I think happy to discuss offline.
Okay.
Thanks for the call out, Bala. Yeah. Any recommendations on how to generate training eval data using LLMs, especially on handling bias, randomness, improver signals? Human in loop needed here. Yeah, I think initially, I think for the first few, human in the loop is good, and yeah, maybe as a good starting point, I would recommend creating evals on this OpenAI. I think this is something that you can check out. They have like something called an evals API. So yeah, so I think this is something that you can start off with, and they should be also helping with all the guardrails that you're talking about, right? This could be a good starting point. Yeah, yeah, I think that's
That's it.
yeah, that's what I had. Cool. I think Bala, let me know if you hear about there's like more interest in terms of actually doing a live example. I know I was not able to prepare one today, but I think even the content did go over time. But yeah, but I would happy to come back again and just share like a live workshop kind of an example. Uh,
Yeah, I think we would definitely appreciate that. I would definitely like it, but let me get a vibe check from the the community also. But the session was brilliant. I could see that there is more stuff to actually share, but the 1 hour is not enough. So we'll definitely set up more sessions. So
yeah.
Sandhya, I know it's very, very late for you over there, and thanks for spending the extra time answering all these questions very patiently. I really
Yeah,
appreciate
I
it.
think it was a good way to spend Friday night. Yeah.
Yeah, awesome. Okay. All right. So if there is nothing else, then we can wind up at this point.
Sure. Yeah. And I can share my LinkedIn in case people want to connect. Yeah.
Yeah, and also do share those resources that you showcased in the call, so we
Okay.
can add it to the video itself. So they will upload the video on Monday, folks. If you have missed something, just you want to go back and look at it, you can look at it at that point in time.
Sounds good.
All right.
All right.
Super. Thank you, folks. Have a good weekend. Take care. Bye-bye.
Bye.
Bala, you were saying I can ping Sandhya, right? Where on the OpenAI club? Sorry, Applied AI club. You are on mute, I think, if you're speaking.
Yeah, sorry. Are you part of Applied AI Club, the WhatsApp group?
No, I have not. I will join it right
Yeah.
away.
Just join. You can just apply on the website. I'll add you, and then Sandhya is part of the group too.
Okay, thank you.
Right? Thanks. Bye.